So just be conscious of that. But the benefit of that is it means that we can make it available on our blog, and we'll share the link in the meetup group as well, just in case you weren't able to make this or previous sessions, or you did want to share it with anyone else who might be interested. Cool. So welcome everyone to our PowerBI4Enviro's meetup session. I think maybe it was last month, but I think we're close to running this group for 2 years now, which is incredible. We started it just as a way of connecting and learning more about how people are using Power BI across the environmental industry, really to share case studies, learn new tips and tricks, and empower other Enviros on their Power BI journey. So I think the group is maybe 1,750 and growing strong. So thank you so much, everyone, all of the new people joining for the first time and our regulars who dial in most months as well. Just a bit of housekeeping as a reminder. I think everyone's well and truly used to using Teams at the moment, but please just make sure you've got yourself on mute when you're not speaking. If you've got questions as we're going through, please type in the chat and the panel will answer them in the Q&A session at the end. I'll also take a break in between each of the, I think I've got 3 demos, just to call out to see if there's any questions as we're going. So just a reminder, the session's being recorded and we'll share it afterwards. And also a Teams tip. This was from Matt Burr ages ago. You can zoom in on shared content from our presenters by holding Control and scrolling with your mouse. So if things are a little bit small on your screen, you can do that as well to zoom in. Before we dive in, I just want to acknowledge the traditional owners on the lands in which I'm presenting from today, so the Bunurong and Boonwurrung people of the Kulin Nation, and also pay our respects to wherever you're dialing in from as well. A special thanks to our event sponsors at DiscoverEI. So at DiscoverEI, we really do focus on transforming environmental data into decisions, and we provide a range of different kind of skills or consulting services. We do Power BI training and mentoring, Power BI custom visuals, end-to-end BI reporting. We also do a bit of design, so if anyone's keen on infographics and animations and incorporating those into Power BI, as well as environmental analytics. So today's session is all about DAX for Enviros and sharing common DAX patterns for environmental data. So as I mentioned previously, our session today, I'll run through some common DAX patterns from a range of different environmental applications, such as calculating species richness and abundance, tracking our groundwater usage and remaining entitlement volume, having a look at averages and moving averages to analyze trends in climate data. And then in the second half of the presentation, it will really be a free-for-all. So it will be an open Q&A discussion with Greg Nash and Sam Fischer, who are 2 DAX gurus. So just make sure that you've got your DAX questions ready. As I mentioned, feel free to type them in the chat, and we'll do our best to help out. Awesome. So before I dive into a couple of practical DAX for Enviro's DAX patterns, I just wanted to give a quick introduction into what is DAX for those of you who are fairly new to Power BI and haven't got started exploring DAX. So DAX is Power BI's calculation language, and it stands for Data Analysis Expression. And we can use DAX to calculate tables. So create new tables within our Power BI report and link them up to our data model. We can also use DAX to calculate columns. So if we wanted to add another column to one of our tables and perform a calculation, a little bit like what you would be used to doing in Excel, we can write DAX there. And we can also write DAX measures. So DAX measures is really, I like to think of it a little bit like a virtual calculation. Where we store the calculation, very similar to kind of how pivot tables work. And the calculations, they're computed based on the report interactions and how we're using them within the report. So today, all my patterns are actually going to be focused on DAX measures. But if you're asking, but why would I want to know DAX? You might be out there using Power BI very successfully. You can create all these interactive visuals and things like that. Why do I want to spend time, effort, and brain power learning DAX? If you want to create anything dynamic, then DAX will quickly become your best friend. So if you want to create things like dynamic titles based on different scenarios, if you want to analyze trends over time, such as comparing stream flow this year to last year, identifying outliers, if we want to calculate things like moving averages, long-term averages, cumulative totals, perform scenario testing, the list is endless. So if you do really want to take your Power BI reports and analysis to the next level, then I would really advocate for investing a little bit of time into exploring the world of DAX. So with that quick intro, I think the best way to learn DAX is just to really kind of see it in action and start practicing and playing around with some of the different DAX formulas. I want to dive into my first example. So in this example, we want to calculate species abundance and richness. So let's just understand what our scenario is. So let's imagine that I'm an ecologist who is completing an ongoing fauna survey. And I want to track both the species richness, so how many different types of species were there, but also the species abundance. How many individuals did we observe per species? So I've imported my data into Power BI, but where do I start? So let's just have a quick look at the data model. We've got a very simple data model here. We've got a date table. We have some fauna species details as our other dimension table. And then we have a table of fauna observations. So we can see, if we have a look at our fauna observations, this is our fact table or our transactional table. This is where we are storing all of the information. Say we went out to site on the 29th of October, 2010 to site 7. We spotted some species, I'm not going to try to pronounce that one, and we observed 3 of these. So these are our number of observations here. So if we have a look and think about what it is that we want to calculate here. This is some pretty simple DAX measures, a group of kind of DAX calculations, which are known as aggregators. So aggregators allow us to easily aggregate our data, like whether it be we want to count, we want to sum up, we want to average, calculate the min or the max. So we're going to start just by exploring the simplest DAX function, sum, to calculate the species abundance. So I want to go ahead and insert a new measure into my table here. So to do that, we can select the table where we want to store our DAX measure. And we right-click on this table and we can click New Measure. So this inserts a little calculator symbol into this table. That's the symbol for measures. And here we can start writing our calculation. So anything to the left of the equal sign, this is what we want to call our measure. And I always recommend naming your DAX measures using kind of plain English, something that's very easy to understand. So we want to calculate species abundance. And species abundance, if we remember, this is how many individuals did we observe. So this is really just the sum of our number of observations. So that's our first measure here, species abundance. So I'll just zoom in here. When we're writing DAX measures, one of the best ways to kind of review and have a look at what's going on with our DAX and to check the calculations is to have a look at it in a matrix or a table visual. So I'm going to drag in a little bit of my hierarchy here for my different kind of species. And then I'm also going to drag in my new measure here to the values, my species abundance, just so we can see how it's being calculated. So we can see here that across this, if we zoom into a smaller time period, we've got 19 bumpy rocket frogs, 2 common green tree frogs, and so on. So this is a really good way of checking what our DAX calculation is doing. And then we can cross-check against our raw data as well, just to make sure. But if we want to kind of see our DAX in action, usually we wouldn't want to present our results in a table or matrix because it is kind of hard to visualize and compare trends or compare how much is being recorded, things like that. So here we've got a clustered bar chart. If I drag my hierarchy in again and bring in my species abundance, now it's really obvious that birds have, we have the most number of sightings of birds. And then if we wanted to drill into this a little bit more, we can see if we keep kind of drilling down to the finest scale here, that the banded honeyeater has the most number of sightings. So that's the first DAX measure, very simple, just using some. The next DAX measure we wanted to think about for our fauna survey is calculating species richness. So it's a little bit more complex, and this is how many different types of species were there. So this time what we want to do is we want to count up the distinct number of species. We don't want to sum up every observation, but what we want to do is if we're out at site and we spot a cane toad on one occurrence, then we don't want to double count that if we see it again and again. So that's what we mean by species abundance. Oh, sorry, species richness. So here I'm going to insert a new measure, and this time we're calculating species richness, and we're using a DAX function called distinct count. So distinct count, it counts the number of distinct observations within a column. So if we bring up our column here, this time we don't want to count the number of observations. We actually want to count the number of kind of species or our scientific name in our observations table. So it's this one here. And if we bring this into our matrix visual here again, just to compare, we can see that there are 16 different types of amphibians which were recorded over these surveys. And then we can see at the lowest level, we only ever have a species richness of 1 for each individual unique species, because this is the lowest kind of grain of my table here. And if we have a look at this again in a visual, just so we can see in a little bit more detail, species richness, we can see again that birds were both the most abundant, but also the most rich in species. We have 50 different species observed over this time period, whereas only 23 different species of reptiles, and so on. So there are 2 kind of fairly straightforward DAX patterns, just summing up and doing a distinct count. I'll just check if there are any questions at this stage. I think, no, it's just all about the recording. Yeah, we'll make the recording available afterwards. Awesome. So this was fairly simple, just to kind of whet our appetite. Our next example here, I really want to showcase how DAX makes time intelligence calculations really quite simple. And this time we're having a look at a function called total YTD, or year to date, to calculate the cumulative total for our groundwater pumping. So in this scenario, let's imagine I'm a water resource manager of a small town where my primary water supply comes from 3 groundwater bores. So I want to visualize my annual groundwater usage to see how I'm tracking compared to my groundwater extraction license. So again, if we have a look at our data model, you can see very nice, simple star schema here. We've got a date table. We have some supporting bore details in a table. And then we have this table here, which stores our groundwater pumping volumes. So if we have a look at our data here, we've got, these are actually weekly extraction volumes for the different bores. And in our bore details table, this is where we have our annual license extraction volume and also a weekly license extraction volume. But the one we'll focus on today is having a look at how we're tracking with our annual usage against this license extraction volume. So as I mentioned, we want to use the DAX time intelligence functions. So they make calculating trends over time a real breeze in Power BI. And we're going to use total YTD function to easily compute the cumulative total usage. And I'll show you how we can do this for a calendar year or for a financial year. So let's start. I'll actually start simple. We want to calculate first a measure just to sum up our groundwater usage. So I'm just going to call this one total groundwater usage. And just like we did in our other example, we're just going to sum up our groundwater extraction volume here. And I'm just doing this because I want to have a look at what is my total groundwater usage in a chart. This is a column axis. So here we can see our total groundwater usage across the different dates. This is for the 3 bores added up. So now we've got this total groundwater usage. Let's go ahead and insert a new measure to calculate our cumulative groundwater usage. And this is really where those time intelligence functions come into play. So we've got this total YTD, and this evaluates the specified expression, which is going to be my total groundwater usage, over the interval, which begins on the first day of the year and ends on the last date in the specified date column, after applying any specified filters. So my expression I want to evaluate is just this simple sum of groundwater usage, or the total groundwater usage. And the dates we want to evaluate this over is just the dates in my date column. So if we just leave our DAX expression like this for the moment, I'm going to drag this in to my chart here. I'm putting it on a secondary axis here just because it's got a different scale. And if we zoom in to a certain period here, we can see that we are calculating the cumulative usage, and it's resetting at the start of the next calendar year. So that's what this function is doing. If we wanted to really check it, that's where having a look in a matrix comes into handy. We can bring maybe financial year, a month, and date. We'll bring our total groundwater usage and also our cumulative groundwater usage into here. And you can see when we're having a look, wait, this is financial year. Oh yeah, I've got it, it's financial year. We'll have a look at that in a little bit, but you can see when we're having a look, okay, yeah, the month scale. Yeah, what we really do need here is calendar year instead of financial year. We'll have a look at this. So here because our cumulative groundwater total, that is just resetting at the calendar year. I've dragged calendar year into my matrix, and we can see at this scale, our total groundwater usage and cumulative groundwater usage, they match. And that's what we would expect, because cumulative is just adding up our usage over that calendar year. But then when we drill into the detail of the specific dates, you can see here that we've just got, if we have a look maybe at June, this column here is representing just the total groundwater usage for June, whereas this tracks the cumulative usage, and it's adding up each kind of subsequent usage. So this is a really good way just to check our DAX functions. If we did want it to reset at the financial year, which is really common when you're reporting on water data, then we can add that in to our DAX measure here by applying a filter and also telling us what the end date is. So the filter we want to apply this over is the same date column of our date table. And the end year date, I want to put as the 30th of June. And if we put this in here, we can see that our DAX function has resulted in our cumulative totals resetting on the 1st of July for every year. So if we have a look here, now we can see a mismatch with our calendar year against our total groundwater usage and our cumulative. And that's because it's resetting our calculation based on the financial year. So if we bring that in here, now we can see that they match up. And if we have a look here, you can see that our cumulative usage resets in July. So this is a really powerful calculation. We can have a look if we add maybe our annual total, our annual license extraction volume here to our line chart. You can see now at a glance for all three bores that combined we exceeded it in 2016 and maybe in 2029. And then we could drill into the detail of just filtering on specific bores. You can see bore 1 also exceeded in those years. So did bore 2, and so did bore 3. So they were all kind of problematic around those periods. We could also kind of take it to the next level just by using a little bit more DAX to track what is our remaining license entitlement volume. So here we can see it really clearly visually on this chart, but maybe we want to know at this stage, just how much do we have left to use for that year? And this is where DAX becomes really powerful when we use something known as measure branching, where we're writing slightly more complex measures each time, but it's pretty simple because we're going to reference previous measures that we've already calculated. So this time what we want to calculate is our remaining license volume. And this time we want to sum up our annual license extraction volume. And then we want to subtract that measure we just calculated for our cumulative groundwater usage. And if we have a look at what this looks like in our matrix here, we can add this one in. And we can see where we're going over. So you can see here that we've only got 31 or almost 32 megalitres left for the financial year, and then we're going into the negatives here. So that's a really good way of kind of just having a measure to track how much remaining license volume you do have. So that's the second example, all about groundwater extraction data. The third and final example I want to show everyone today is having a look at rainfall trends. So using DAX to calculate long-term averages and moving averages. So the scenario we want to have a look at is, let's imagine that I'm an environmental engineer who's interested in analysing trends in the average daily rainfall for a local rainfall gauge. So while I know how to chart the daily rainfall, there's a lot of noise in the time series, and I want to smooth out the noise by plotting the monthly moving average. And I also want to know if the rainfall is above or below the long-term daily rainfall average. So again, a good place to start is by having a look at our data model and what the data actually looks like in our tables. Here you can see we've got a very simple data model. We have a fact table, which is just our climate data, and we have a supporting date table as well. So we only have one rainfall gauge in this example, but we've got daily data for rain and evaporation. So let's have a look. Let's start by creating or calculating a very simple measure just to compute the average daily rainfall. So I'm going to insert a new measure into my climate data table, and we're going to calculate the average daily rainfall. And let's have a look at this in a line or a time series chart, in a line chart, and also in a matrix as well. So here, actually, we'll start with the matrix because I'm already on that. I'm going to add the year and my date, and let's just bring this in. So here we can see our average daily rainfall across the year, and then we can see the daily rainfall for every date. So if we have a look at this in a line chart as well, have a look here. We'll put date on the x-axis and our measure for the y-axis. And you can see we've got a lot of data. We've got lots of dates here. Rainfall data can be quite kind of noisy, lots of extreme events and things like that. So what we want to do first is have a look and see, is our rainfall above or below our long-term average daily rainfall? But what is our long-term average daily rainfall? So this is where we can use probably what's known as the queen of the DAX functions, calculate, to help us out. So calculate evaluates an expression modified by some sort of filter context. So it's really powerful. It allows us to really kind of calculate a much more complex expression. So let's have a look at it in action. I'm going to insert a new measure. And this measure we want to call long-term average daily rainfall. And we're using one of my favorite DAX functions, calculate. So calculate evaluates an expression in a context modified by filters. So the expression we want to calculate is the one we just made, the average daily rainfall. And the filter context, what we want to do, because this is our long-term average daily rainfall, we want to calculate it across all of our dates. So we're going to use a function called all, which returns all the rows in a table or all the values in a column, ignoring any filters that might be applied. So I want to apply this to the date column here. So if we have a look here and if we drag in our long-term average daily rainfall, we'll put it here, we can see that it is much lower sometimes than our daily rainfall. And that's probably because we've got lots of no rainfall events here. And this chart here, it's very skewed by the very extreme events. If we zoom right in, we can have a look at that. You can see we've got lots of periods of no rainfall with only a few really kind of sharp peaks. So that was calculating the long-term average rainfall, and this is for the entire period. But what if we wanted to calculate maybe the long-term average rainfall, not for the entire period of record, because that is a very big record here. We've got data we've downloaded from the silo rainfall gauges, I think starts back in 1888. What if we want to just calculate it just for the period that we've got maybe selected here in this visual based on my slicer? That's where we can use a function here called all selected. So instead of using clearing the filter for all dates, we might just want to do it for all selected dates. And this returns all of the selected values in the filter context. So here again, we want to apply it to our date column of the date table. And if we press enter, recalculate it. So you can see it was a very minor change. It was 2.38. Now it's 2.3. If we zoom right into a very short period, we can see that our average has changed to 2.35. So that's how you could calculate a long-term average just for the selected period here. But finally, what if we wanted to calculate not just a long-term average, but maybe a moving average? This is where we can use calculate again, but modify our filter context to have a look at just the dates in a certain period. So we're going to insert a new measure here, and we're going to calculate a monthly moving average. And we're going to use our calculate expression again to calculate our average daily rainfall. But this time we don't want to calculate it across the entire period. We want to calculate it just for a very specific period. And we can use a function called dates in period. So this returns the dates for the specified period. So all we have to do is tell it what dates we want to use. So we want to use the date column of our date table, the start date. So this is where we're going to use a function called last date for our date, which returns the last non-blank date. So that's for our kind of given context. The number of intervals we want to do -1, so I want to go backwards 1 interval. And the interval size, we could do this for days, months, quarters, or years. So I just want to pick months. So I'm going to calculate my average daily rainfall, not for the entire period, not for just one day, but for the dates between my last date. So for this example, it would be the 15th of November 2008, all the way back 1 month, and calculate the average daily rainfall for that. So let's press enter and we'll see what this measure looks like when we plot it up. Thinking. So if we add this here we can see we've got our monthly moving average. So it really does take out a lot of the noise of the extreme events here. And if we wanted to have a look at this in a little bit more detail, we can just to double check that it is calculating correctly. It's always a good idea to bring it into a table. So here we've got our kind of monthly moving average. We can see this is the average across all of the previous kind of days of the month. And if we wanted to take it to the next level, so here we've kind of specified it or hard coded it for just 1 month. Here we're just going backwards in time, 1 month. If we want to make this really kind of dynamic, what if I wanted to have a look at the 2-month moving average or 3 months or 6 months? What we can actually do is combine our DAX with what if parameters. And these allow us to really make kind of dynamic, almost scenario analysis or decision support tools. So if we head across into the modeling tab here, we've got the option here for a new parameter, and I want to choose numeric range. So the name I want to give my parameter, this will be moving averages, maybe number of month. And I want to be able to select a value from 1, maybe to 12 at an increment of 1. And the default I'll give it is 1. And what this does is it actually just helps us out by creating a new table. Here we've got a table which is added into our report. And this table is an example of a calculated table where it's been calculated using DAX. So it just generates a series from 1 to 12 with an increment of 1. But it's also inserted a measure for us, which returns the selected value of this column here. Otherwise, it just returns 1. And that's just taking the value from this slicer here. So if I just add a card, we can see what this measure gives us. It just returns whatever value here is selected in this slicer. And this isn't really doing anything at the moment. This table, it's disconnected from my data model here. It's updating this card, but it's not changing my calculations yet. If we want to tie it into our calculations and make a dynamic monthly moving average, then what we can do is just simply edit this measure. So here I want to do -1 multiplied by that measure for the moving average number of months selected. Here, if we press enter, it's got a little bit of a lag. Still thinking, thinking. We can see that that smoothed it out a lot. And if we increase this to maybe 5 months, it should smooth it out even more, where it approaches that long-term daily average pretty soon. So hopefully that's helped kind of spark a couple of ideas with you of how you could use DAX to compute your different kind of environmental analysis. With that, I might stop sharing and hand it over into just our open kind of panel discussion with Greg and Sam. And this is really your opportunity to ask your DAX questions and learn a little bit more about how we would approach different DAX problems and challenges, but also hopefully solve a couple on the spot. Oh, so just having a look through the chat. Greg and Sam, did you see any questions pop up in the chat which you didn't answer just yet, or?
Yeah, I think there's one from Jan or Jan. So what's this? Love the dynamic moving averages using a parameter. Cumulative totals. I found a workaround a while back for avoiding the annual reset in a cumulative total. Do you have advice on the best way to do that in a running total? Yeah, that's an interesting one. Like, it kind of comes down to, I guess, understanding your filter context. So as Alice has kind of demonstrated, you do need to do a bit of iteration to work out the best way to work out how to calculate the range that you want. I usually take the starting point of trying to get an understanding of what you want to appear on the chart, if you're doing this chart, and then working out what are all the filters that are being applied. And then from there, having a think about, okay, how do I need to change those filters? So if you're looking at, say, an individual date, and you want to say, I don't want the value for that date, but I want it for all of the values that are coming up over a given range, then you might say, I've got to use, say, a dates between function or a dates in period, where I'd select the first date that I want to use, which might be like something like a start of year function. I always get mixed up with PowerBI and DAX as to the names of it, but Google's always your friend for that. And then the end date might be the currently selected date variables can help to define that as well for performance. And then you can apply that there. Hopefully that helps to answer that one.
Yeah, no, that's great. And I think you're spot on there. Google's always your friend when it comes to DAX. It's knowing what functions, you just have to know a little bit about what functions to Google as well. But there's lots of patterns for the cumulative total. You don't have to use year to date. You can, just like Sam mentioned, you can use calculate and then put in your different filter contexts there. Did you have anything to add to that, Greg? Or?
No, I think you guys are kind of nailed it with the. It sounds like Jan was specifically talking about maybe a reset. So we probably have to look specifically at what exactly that was doing there, and we'd be able to maybe help out a little bit more. But maybe if you can provide a bit more detail. We've got one here from Val that says, when would you use DAX versus creating data aggregates in a data warehouse backend? Which I think is an interesting one.
Yeah.
So DAX is ostensibly, if you need anything to happen dynamically on the front end, and you saw the Alice's demonstration there where she needs it to be calculated in the front end, then that can't necessarily be done. Like as the person interacts with the slicer, or they click on a thing and it recalculates that value, or you're using a what if parameter to recalculate something as the person's interacting, you can't do that in the back end, right? Because in the back end you can aggregate things up, but we can only ever really show that value in that current context, right? And so what DAX allows us to do is have the end user of your report manipulate that context. They can select, these 3 sites, and it'll recalculate that value on dynamically for that person. And when you're talking about some of these more complex values, like your cumulative totals or your moving averages and other types of things, that's where DAX really comes into its own. It's using it to dynamically calculate values.
Yeah, and I'd probably add to that as well, depending on the measure that you want to present, that can help inform where you want to calculate it. I see a lot of cases where people try to do non or semi-additive measures. An example of that might be, it's easy enough to do like counts, but if you have percentages that you want to present, say you've got an aggregated percentage of a value for January, February, March, it's hard to roll that up unless you have the underlying numbers for the numerator and denominator. So you sometimes need to store the base values rather than aggregated percentages, or oftentimes you might even have to go to the full transactional. It kind of depends on what you're trying to calculate, but it's always good to keep those things in mind.
Yeah, definitely. I think, what is it? You push it as far upstream as possible and downstream as necessary.
Yeah,
exactly.
Roche's maxim.
Yeah.
Matthew Roche's maxim. That's right.
Oh, it's a tricky one. I guess it depends. But yeah, just building on Sam's point, with the DAX, just be mindful. You could do lots of those calculations, maybe potentially upstream. Like something that we do a lot of is calculating the number of exceedances above maybe a threshold or things like that. But if you do that, then it can change the grain of your data and then add another fact table in, which kind of complicates your data model as well. So it's just thinking about whether it's beneficial to store it upstream. If it is like an organizational calculation that you are reporting on, maybe to the EPA, then you might want it stored in a data warehouse because it is extremely important and you don't want people modifying the DAX calcs. But if it's just for internal analysis, you don't really want your data model clogged up with lots of different iterations of potential calcs as well.
And I think that idea that data modeling and DAX go hand in hand, right? The DAX is so reliant on a good data model to be if you want to have simple DAX, you really need to build a really good data model, and having a good understanding of DAX is also a way that you can potentially avoid building things into a data model, right? So there's a tendency I've seen in some places where people build year-to-date columns, for example, in their data, in their fact tables, and that's actually not necessary in Power BI. It can be calculated in the BI tool, and so you don't need to then have that processing where it's calculating a year-to-date column or a cumulative total inside which is a non-additive, column. It doesn't really work in any grain except for the one that you calculated in that table. And so there's the two disciplines work hand in hand, and you'll see a lot of the DAX gurus out there, like SQL BI guys, and those guys are out there. They're doing data modeling and DAX as their two things, because the two are hand in glove. You need a good data model to write good DAX, and vice versa. Otherwise, your DAX gets messy, and your model can be, if your model's no good.
Yeah, for sure. We have a question from Patrick Booth. This is a good one. Are there any workarounds yet for quick measures using a date table that is not a Power BI self-generated one?
So I'm assuming he's referring to the error message that comes up when you do a quick measure and you try to filter it by a non-generated Power BI self. Is that what everybody else is interpreting this as?
Yeah, it's when you try to use the quick measures, I think like a cumulative total, which relies on a date table, but
it says, so you'll notice in the code of the quick measure, and I don't know if Alice can demonstrate this, but in the code of those quick measures that get generated, there's an if is error, or is if filtered calculation on the date that you bring in. If you remove that error checking on the date table, it'll actually work with any date table. Your quick measures will just work. I'm not 100% sure. Darren might be. I don't know if Darren.
Yeah, hold on. I have to mark. I have done something naughty. This is demo data set. I just have to mark this as a date table.
Mark it as a date table. Yeah.
Oh, unmark it. Okay, so it is. Hold on. Oh, right. Yeah, that I'm in my date table here.
You're in a date table.
Mark as date table. That is a date.
It's already marked.
It's already marked, but it let me do it. Hold on. Add.
Because it's marked, I think.
Okay, previously this
if your
date
table wasn't marked as a date table, you would get the if is error thing, I think.
No, I think even if you did mark it, they must have
Okay.
changed it, maybe with the new suggestions, quick measures. I don't
maybe.
know. Maybe Darren knows more about this, or
Nope.
No.
Short and sweet.
Short and sweet. Thanks, Darren.
I was going to say, if you mark this date table, does it work? And
yeah, it is marked as date table, and it works. I thought previously, I swear it didn't work.
It would wrap it in an is error, and because I did it the other day in Power BI, and it wrapped it with an is error. So there must be a scenario where it does do that.
Okay.
Now
I was going to ask. I don't know if that applies to this function. It might do. Like, I know the is error. I sometimes see it applying to some of the quick measures, and
maybe a rolling
average. Not applying, perhaps.
Yeah, try one of the other measures.
Here, this one, rolling average.
There you go.
So then what's the workaround? Can I still click add it, Greg?
Only Power BI provided date hierarchies are supported. So it's complaining about that. So what you do, if you unmark your date table, I think it'll allow it.
Okay, and press OK.
Oh yeah, unmark.
I'm unmarking. And now.
Oh, you do have auto date time turned off? You probably do, because
you know what I'm doing.
Do it. Yep.
Can I put that in? No.
Yeah. So what it's saying here. No, because you've got auto date time turned off.
In my
options, you'd need to also turn on auto date time. Yeah. So it's what it's saying is So Alice is just going into the settings here. Under your report settings, there's an auto date time feature, or is it data load?
Current file, maybe.
Data load. I think it's under data load.
Yeah, I think you're right.
Yeah, there it is. Auto time intelligence, auto date time.
Yeah.
Oh, okay. So you have to have that turned on, and
need that on, and then it would create that automatic Power BI hierarchy. And then it would allow that. So it's something about those particular quick measures were written in a time where they only allowed that, and they put in that if is error. So if you want to work around it, though, you can. What you would do is, if you want to use that quick measure and you're not sure how to write it, you could unmark and have your date hierarchy in there, drag that in, it'll work, and then you can remove the if is error business and only just then steal the actual piece of code from the middle. So you can kind of copy out the code that is just the actual measure, remove all the error checking, And that will still work with any date hierarchy. So you can kind of work around it by hacking it, I guess, is the answer.
Ah, that's good.
Yeah. Like the tricky thing is when you know the tool well enough to turn off auto date time,
Exactly.
it
You don't
cripples
need
you in
quick
terms of
measure or
having these
whatever.
easy to use
Yeah.
features. Like I often find as well, rather than using the embedded quick measures dialog box here, using some of the community content, like looking up SQL BI and their DAX patterns, you can often just copy paste the code from there as well. But then you, of course, have to adapt it a little more to your particular use case.
Yeah, I think it's some of those early like the original quick measures had all this error checking in it that it was almost not necessary. That I remember being annoyed by it when they first came out, being like, oh, why do they put all this error stuff in there that it's just going to make things more confusing for people and make it harder. But
yeah, exactly. If the goal is to learn it, then the error checking is like further down the line than learning it the first time.
Yeah.
Yeah, for sure. Oh, awesome. Oh, good you know a workaround, Greg. That's cool. There's a good.
Oh yeah, go. You go.
Oh yeah, I was gonna say there's a question just before Bianca, Veronica, how to share measures in different reports. That's a good one. Any ideas, Sam or Greg?
I'm just
Copy
trying
paste.
I'm just trying to picture the context, how to share measures in different reports, whether that's like a golden data set thin report approach or
that's true.
Could you use, if you're rolling out if say you have lots of similar DAX patterns, say you work for a finance company and you've got all your financial DAX patterns, could you potentially script them up in something like Tabular Editor and then use that as a reusable way of kind of writing them to reports, as long as you have a very similar data structure and naming conventions for columns?
Yeah, that's definitely a good one, and it brings to mind.
In the tabular model, right?
Oh, sorry, could you repeat that a little bit? It was breaking up.
Couldn't you put them in the back end in the tabular model, and then everybody would have access to it instead of being report specific?
Yeah, exactly. If you've got that set up of a central data set or a golden data set and multiple reports off of that, if there's a measure that's specific to one report, then sure, it makes sense to put in that report. But if it's going to be used across multiple, then it makes more sense to put it upstream into that central data set. I think as well, Alice, to add to the idea of scripting out in Tabular Editor, you pointed out a good challenge that you'd have to adjust some of the fields that you use. And it brings to mind, there's also a few community tools out there that actually allow you to parameterize that and share it. I think Greg Deckler has one, and there's another one that the guys with PowerBI.tips have. I think it's called DAX Generator. I've put some templates, 1 or 2 templates up for that, but effectively it's an external tool that you can pull kind of DAX patterns from a central GitHub repo, and it's got a simple GUI, so you can pull in columns and measures from your model and paste them into a generic template for DAX, and it will automatically add that to your model once you define it. It's a really, really cool tool. I don't see it, I haven't seen it mentioned a lot in the community, but it's a really useful tool, especially when you've got a lot of repeated kind of boilerplate code that you want to spread throughout your organization in a consistent way.
Oh, that sounds awesome. Maybe paste a link in the chat.
Yeah, I'm just looking for one now.
Unless Param has already done it.
How to copy measures from one PBIX file to another. I guess it does depend on your context there, Veronica, whether you're trying to do boilerplate code that is repeatable across many reports, or whether you just want your measure, like your model and your measure, to be then people to build new content on top of those models and measures, but you're only maintaining that model, in one spot. Then you would use the other pattern, which is this golden data set pattern, sharing just the data set to people so that they can build their own front end content on it, and then potentially extend it with their own measures as well.
Yeah, awesome. have a look through. I think we might have missed. There's lots of conversation happening in the chat, so thanks everyone for jumping in and answering different questions. If you did have a question, please feel free to go off mute. I'm just scrolling up through the chat to see if we.
I've got one from Bianca. It says, performance-wise, when you want to add icons in a table for a text field, is it better to create values via DAX or Power Query conditional column? For example, completed equals 1, in progress equals 2, draft equals 3.
Yeah, that's an interesting one. I think the usual attitude kind of comes from, again, that maxim of as far upstream as possible, as far downstream as necessary. I'll point out that depending on your use case, it can change the approach that you take. So I know that Marco Russo has a good attitude of, only do things in like a DAX calc column if you're not bringing in any extra data. And that's reasonable enough. I think in that particular example that Bianca, that you've given around completed equals 1, in progress equals 2, that kind of use case, I'm guessing, is oftentimes when you want to do a sort by column. And when you do a sort by column as like a conditional if statement in a DAX calc column, you can't actually set it as a sort by on the column that it's based on. So that's where you would definitely want to push it upstream to Power Query. In general, I tend to try and push things upstream to Power Query as much as possible, and only use DAX where you kind of don't have a choice, whether that be through performance or otherwise.
There's an important consideration around this DAX versus M thing, which is compression, right? So the way compression works in Power BI is that after your Power Query runs, all of that data gets compressed, and then all of your DAX calculated columns get created. So your Power Query columns are compressed and your DAX columns are not. And so that's why the general rule is always move columns to Power Query. The only time you are going to run into situations where you need to create calculated columns in DAX. The best practices for those are create those in dim tables wherever possible, not in your fact tables, because of that compression issue. They will then ensure that your fact table remains a bit smaller. And also, you'll need to use DAX if you ever need to refer to another table in the model. So sometimes you need to do a calculated column that refers to another table in the model via the relationship, and you use the related function or the related table function. Those two functions are only available in DAX. And so you would, in the equivalent in Power Query would be, you would need to first merge that table, then expand it out and take that thing via a join, if you like. And so it's quite easy to do that in DAX. And so you're going to have a situation potentially where you would do that in DAX. But the key thing to keep in mind when you're creating calculated columns is that compression will not apply in the model to those columns if you do them in DAX. It will only apply to columns that are done in M.
So can I add something?
Yep.
They've actually fixed that.
Oh.
So it does now compress calc columns, but it can't, because they're calced. You're correct. They are calculated after the data's loaded, so it can't take the contents of those calculations into account when it does the compression. So the Vertipack engine will evaluate a whole bunch of different sort orders, and so it can't take those calc columns into effect. So you often end up with less efficient compression on those columns, but they are now compressed.
They are compressed,
which wasn't the case initially. Yep.
Excellent.
I can't remember when they did fix that. So they are compressed, but they're probably not compressed as well as if you load them with Power Query. So,
yeah. No, I think just to add to that, and Darren, please correct me if I'm wrong, my understanding as well is that I agree with that approach for calc columns. I think my understanding with calc tables is that because the evaluation is done for the whole table in one step, then that will be optimally compressed with the optimal sort order for the most compression. But yeah, again, you only want to do that if you're not introducing new data or you're aggregating additional kind of things. Like usually your best bet is to do it upstream in Power Query, even in SQL if you can.
Oh, awesome. Thank you. For those of you who haven't met Darren Gospel, he's the creator of DAX Studio, an awesome third-party tool. And I think you're also working at Microsoft now, Darren.
Yeah, I joined the CAT team a few months ago.
Congratulations,
our
helping
local
everyone
cat
with all
team.
their
That's right.
DAX and Power BI and challenges. Awesome. Oh, thank you so much. I think I just note we're just on time. I might just share a couple of things just to close out, but I'm happy to stay on the line for a couple of minutes, a little bit extra if people have a few more DAX questions, and maybe Greg and Sam stick around for another 5 minutes if there are some extra ones to close out as well.
For sure.
So just a heads up, our next session, we've got another DAX guru,
Awesome.
Matt Arlington, presenting next time on using Power BI to track the recent Australian floods. So he's been sharing lots of interesting ways of using DAX and Power BI to track the floods, I think specifically focused in South Australia, where he's got a family home there. So it'll be really good to hear a real world practical application of using Power BI to analyze some streamflow data. And I'll also share a couple of other ways that we have seen Power BI used to have a look at streamflow data as well. So that's happening 13th of December. And just a reminder for anyone who jumped on late, we are recording this session and all our previous sessions, which we share on DiscoverEI's YouTube channel and blog if you did miss anything or wanted to catch up as well. And if you've got a Power BI, really interesting Power BI use case or case study or something to share where you've worked on an environmental example, we'd love to have you come along and present. Doesn't have to be for the full 45 minutes or an hour. It could just be a real quick session, maybe 10-minute tips or something. So please, we're always looking for people to come and present. So please get in touch with Christian if you've got an idea or you want to nominate someone else as well. So thank you so much once again for dialing in and really interesting questions there shared. And thanks to Greg and Sam and everyone else who's typed in the chat for all of your expert Power BI and DAX tips. These guys really are the experts. Cool.
So
I
have a question before they go.
Awesome.
So this is Ed